Hello dear champions, welcome back to our new series, that is Decode NCERT. So today in the first class of Decode NCERT, I have chosen the chapter Solutions, which has a weightage of 12 marks in a PU board, right? 12 to 13 marks. So I'll be telling you first the purpose of this series. The purpose of this series is to save your time, okay? So I'm not going to teach you this chapter. You have already learnt it in your school. We have our KCET videos to understand the concept. We have the Brahmastra videos to question practice. So what exactly I'll be telling you here? So I'll be seeing the whole book. I'll be showing you the whole book, and I'll be telling you which are the important points that you need to remember, how to answer, which are the points from where questions can be asked. So these all things we will be discussing. So it will be a short 15 to 20 minutes of video where I'll be telling you all the important things that you need to study from NCERT. So once you see this video, you just need to go and study that part of the book where I have told you to study, okay? So now I want all of you to sit with your NCERT book, a highlighter, a pen, and you can take like one black pen and blue pen and one highlighter. You can set and start this class, okay? So now let us go here. The first thing, let me zoom out, let me zoom for this one, okay? I hope this is visible to all of you, right? Okay, so now if you see the first part that you should remember here, okay, in the introduction part, there are certain alloys that is given to you, okay? So like for example, let me zoom here more, okay. I think now it is visible. So now you can see brass is a mixture of copper and zinc. German silver is a mixture of copper, zinc and nickel, and bronze is the mixture of copper and tin, right? So this part of the chapter, the introduction part, this part you highlight and note down, and you need to remember these alloys, okay? First thing done. Now we will move towards this one. So here are certain definitions that you need to remember. First is homogeneous mixture, so just underline this one. Then solvent and solute, I think all of you will be knowing, so I have not kept that. Binary solutions also, I think all of you will be understanding. Now we will go to this table, okay? So this table, as you have written, as I've seen, it is very important table. MCQ questions can be asked here, okay? So MCQ questions can be asked where you can see the different types of solvents will be given, which is the solute, which is the solvent can be asked, or they can ask you give an example of gas solution, okay? So this table you have to remember completely, okay? You have to remember the example and you have to learn this table completely. Next we have concentration. These all formulas you should know, mass percentage, volume percentage, okay? Formula only you should remember. Then you have mass by volume, parts per million, okay? Mole fraction. Up to this is there. Then you have molarity and molality, right? Nothing else you should know here. Only you need to know the molarity formula, and then going forward we have molality formula, okay? So concentration terms, 7 concentration terms are there. You have to know the formula of all the 7 concentration terms, okay? Highlight this part in your book. Next we will go towards, these all examples also you need to solve. For the solutions chapter, make sure that you are solving all the in-text questions and the solved examples, okay? So this is the first set of solved in-text questions, so you need to solve this, okay? Now we will come to solubility. So again there is a definition of solubility. What is solubility? Question can be asked from here. So solubility of a substance is its maximum amount that can be dissolved in a specified amount of solvent at a specified temperature, okay? I hope this is visible, okay? So this is the definition that you need to remember about solubility, okay? Now move forward here. Here there are certain things that is given about the solubility of certain elements in certain solvents. So here I will zoom out. You can see here naphthalene and anthracene dissolve in what? There will be 4 options. You should know it is dissolving in benzene, okay? Next we will go here, what is the definition of dissolution and what is the definition of crystallization. You can see here this process is known as crystallization, and when you dissolve a solute in a solvent, it is called dissolution. When a solute comes out of the solvent, that is called crystallization, right? These 2 definitions you should know. Next we'll go forward here. the definition of saturated solutions and unsaturated solution. Okay, that you should know. Saturated solution means when you have dissolved the maximum amount of solute in a given amount of solvent. Unsaturated solution is one in which you can dissolve still more solute. Okay. Now we will go towards, this one is very important, effect of temperature and effect of pressure. Okay, so what is the, this is what regarding, one second. Okay, so this is regarding the effect of temperature on the solubility of solid in a liquid, right? And this is the effect of pressure regarding the solubility of solid in a liquid. So this you should know. Okay, effect of pressure and temperature. Now we are going to solubility of gas in a liquid. So here the first thing that you should know is we should not bother about any of these things, right? Okay, now here comes the first thing that is very important, Henry's law. Okay, you should remember the definition of Henry's law. After that, what I have in this particular chapter that you should remember is your statement of Henry's law. Okay, this is another statement of Henry's law. So you can write any one of the statement, that is fine. Next, Henry's law graph is important. Okay, so you should know the graph for Henry's law. Practice this graph. Okay, next is this graph that you should know. So whichever points I am telling, please mark those points. Okay, now coming to, okay, now coming to the relation between KH and solubility. So higher the value of KH at a given pressure, lower is the solubility. This one can be asked as a question. This can, its application is also there. So make sure that you understand this point. Okay, now if I go forward, here we have something, then this is a question, reasoning question can be asked from here. Aquatic species are more comfortable in cold water rather than in warm water. So the answer for here is in cold water the solubility of gas is more, right? So oxygen is more dissolved in cold water. Okay. Next we will go to these examples you need to solve, very simple questions, these are direct. Then coming to this applications of Henry's law, very important. 3 applications are there, you need to remember all the 3 applications. Okay, so the first one is for solubility of gas in a liquid, then is from the scuba divers. So in case of scuba divers you should know what is bend. Okay, this is important, please highlight here what is bend, you should know. Next, how it is prevented, for that you should know the exact amount, 11% helium, 56% nitrogen and 32% oxygen. Okay, this composition should be remembered. Next, coming to anoxia, when at higher altitude what happens, that is anoxia you should know. And regarding anoxia you should also know the symptoms, exact symptoms, what happens, weak and unable to think clearly. Okay. Next, coming to effect of temperature. Next coming to effect of temperature. So solubility decreases with the rise in temperature. Okay, now what is the reason for that? The reason is dissolution is an exothermic process. So according to Lee-Chatterley principle, it will dissolve, right? It will decrease. Now coming to the next one is your again in text questions. Here we have now come to vapor pressure of liquid solution. So here you can skip everything. Okay, directly you can go to Raoult's law. What does Raoult's law says here? So underline this one and remember the statement. After this, what we have, you should know this derivation. Okay, this derivation is very important about the Raoult's law. Derivation you should prepare. Okay, after this you have one point here that following conclusions can be drawn from this equation. So there are 3 conclusions. This can be asked as a theory questions. What are the conclusions? That is the 3 points are there. So these 1, 2 and 3 point you should remember and understand. Okay. Next is question number this one, the second graph that you should be doing about the Raoult's law. This graph you should practice. After that we will move, and these all things you can skip, and these 2 formulas also you should remember. Not very popular, these 2 questions are not asked regularly, but yes, you should know the formula. After that, do this, you can do this in text questions. Okay, I am just telling you in text questions we can go. And now this is a very potential question, that Raoult's law is a special case of Henry's law. So you need to write this all total paragraph for that. How, like if the question is asked, explain how Raoult's law is a special case of Henry's law, in that case you need to write about this particular paragraph. This can be a question asked, very probable question. So make a list of this question. Next is about vapor pressures of solutions of solid in liquid. So here the point question is, this is a blueprint question, that is why the vapor pressure, write down the question right now when I am saying why the vapor pressure decreases when a solute is added. So this is a blueprint question also, why the vapor pressure decreases when the solute is added. Okay, so you can see here, from here you need to write if a non-volatile solute is added, right? From there you can mark in the book, this can be a question. Okay, now moving forward we have what, okay, next is we have this derivation. When you have only non-volatile solute is added, then how can you calculate the vapor pressure? Okay, so that's a small derivation here. Okay, so this is not very important, but yes, this graph you can see, and this is a simple derivation where you do not have the second component. Okay, now we will go to something, definitions of ideal solution. You should know what is the conditions of ideal solutions. These 2 points are important. Then what exactly ideal solution means, that is the intermolecular attractive forces are of A and BB, the intermolecular attractive interactions will be of the type AA and BB, whereas in binary solutions, in addition to these interactions, AB type of interactions will also be present. Now if the intermolecular attractive forces between the AA and BB are nearly equal to those of AB, then we call it an ideal solution. Okay, so this is the definition of ideal solution. Okay, one second, yeah, you can see, highlight this part, definition of ideal solution. After that, here this is very important, again the example, sorry, one second, yeah, examples of ideal solution, and 3 examples are given: N-hexane, N-heptane, bromomethane, chloroethane, and benzene and toluene. Okay, next coming to non-ideal solution, and in non-ideal solution you have positive deviation and negative deviation. This is about the positive deviation, right? Interactions are weaker than A and BB. In this case, the intermolecular attractive forces between the solute and the solvent molecules are weaker, and they can escape into the pure state, and this will increase the vapor pressure. So these 2 graphs are again very important regarding positive deviation and negative deviation. After this, what you need to study, this is again very important regarding positive deviation. Okay, examples are important: ethanol and acetone, how they form positive deviation. That suppose the question is asked like how explain why acetone and ethanol forms a positive deviation. So what you have to write, the bonding increases. How does it increase? You have to write down here. Okay, so question here that can be asked is, let me see if I can add pen here. So here the question that can be asked is like why acetone, okay, why acetone and ethanol shows positive deviation, why? You have to explain the reason there. Okay, next coming on, we have next one is your negative deviations. Okay, so one second, this one. So now similarly you should know about negative deviation, chloroform and acetone, phenol and aniline. Okay, so these 2 examples you should remember. Then coming to isotopes, their definitions, then minimum boiling, maximum boiling. Okay, next you have their example of your isotope mixture, these 2 mixtures with the concentration you should remember. Highlight these important points. Next we have regarding the colligative properties. So definition of colligative property you should be knowing. Okay, next coming to the first colligative property, that is the relative lowering of vapor pressure. So you should be able to do this derivation, so prepare this derivation. Next we have this question you can solve. Okay, all the numericals you can solve from there. Next coming to elevation in boiling point. So what do you mean by boiling point, that you should know. Okay, then why the vapor pressure of the solvent decreases in the presence of non-volatile solute. But the question is why, so here you can add a question, why boiling point increases on adding solute. Okay, this is the question and this is the answer. Okay, this is first point, this is second point, and this is the third point that you need to write in the answer. Okay, next what you should remember about the graph you should know. Then you should know this formula. Okay, delta TB is equal to KBM, this formula, the expanded form. Okay, next you can solve this question. After this we have the freezing point, right? So under freezing point also we can have the similar question like why the freezing point decreases on adding the solute. Okay, so this is the answer for that question. Okay, why the freezing point decreases on adding the solute if the question is asked. Okay, here I'll write the question, why, okay, freezing point decreases on adding solute. Okay, so if this is the question, this is the answer that you need to write down. Okay, fine. Okay, now let us move forward. Yes, next is this graph you should remember regarding the freezing point. This graph is very, very important. This answer please take properly, underline it and note down this question. Okay, next again the formula of Kf, then you have this what I'll say, this formula Kf, Kb, this detailed expanded formula, these all things you should be knowing. And lastly, we are almost towards the end of the chapter. In osmotic pressure there are so many questions that can be framed. So first of all you should be knowing about the semi permeable membrane, what it is, then the definition of osmosis, okay, and then you have what is osmotic pressure. Okay, next we have osmotic pressure, then the formula of osmotic pressure, this you will be knowing because you have solved numericals from here. And next you have what are the benefits of osmotic pressure. Okay, where is the application of osmotic pressure? It is used to determine the molar masses of proteins, polymers and other macromolecules. Okay, so this is uses of pi and the reason why osmotic pressure is used for this purpose. So the answer here is the pressure measurement is around the room temperature and the molarity of the solution is used instead of molality. Okay, so that is there. Then it is next is what is isotonic solution, that you should be knowing. Then you have this example question may be asked, they give the example of hypertonic solution. So you should know what is the blood pressure, osmotic pressure of the blood, then what is hypertonic solution that you can use, and what is hypotonic solution. Lastly we will go towards, there are so many examples of osmotic pressure, osmosis here. A raw mango placed in a concentrated salt solution loses water. A carrot, wilted flowers revive when placed in fresh water. A carrot that has become limp because of water loss into atmosphere can be placed into water making it swim once again. Okay, 3 examples we got. Next, this is a very, very important question regarding edema. Okay, so this part, edema, you should be learning what is it. When salt, when too much water enters inside the cell, we face a situation called as edema. Okay, then what is the process in water movement from soil to plants? Then preservation of meat by salting, this also can be a potential question, like why, so how can salting the meat can preserve it, right? What exactly, what osmosis role is there in this particular segment? This is an important question. Next, coming to reverse osmosis, what is the definition of reverse osmosis, application of reverse osmosis? Here it is desalination of water, right? This whole paragraph is important. Next we'll go, and then we have abnormal molar mass. So first of all you should be knowing about the definition of abnormal molar mass. So write down this one, the definition of abnormal molar mass. Then the formula of Van 't Hoff factors you should be knowing. Then how the colligative properties are calculated using the Van 't Hoff factors. Okay, this is there. And now we have done with the question, with the book, right? I think almost it is over. I think we should be now, okay. Yeah, summary is there. So now these, what I found, I went through all the questions of this NCERT and I felt each and every question is important. Okay, so first you need to, and whatever chapters, whatever points I told you, you need to only read that many things, other all things are not required. Those many things and all the graph and derivation that I told you, you need to prepare only those points. Next, what you have to do, you have to solve all the in-text questions and the examples. Now, I want that you should solve these exercise questions also, okay. So, if you want me to solve the exercise questions, we can have a class together and where we are solving at least like 37 questions are there in part 15 questions we can solve. So, do let me know in the comment section if you are interested for this and tell me, was this series or was this video helpful for you, were you able to know now which part you have to focus on the chapter, right? So you do not have to read the entire chapter, you just have to focus on those points where I have told you. Okay, so apart from this, you can just, and reading these all things and remembering will take you hardly half an hour to 1 hour, and with that this chapter NCERT will be done for you. Okay, so that's all students, and thank you for watching and see you soon in the next class.